Welcome folks. In this video I'm going to take you through science paper 2 for the year 2018, and this is a paper that was written by the internals. So let's look at the first question from section A. Which one of the following sublimes when strongly heated? So if we look at sublimation, we are looking at the process in which a solid changes directly into a gas. So from this, we want to look at the substance that undergoes sublimation. So the answer is just the iodine crystals. Then we move on to question 2. Identify the measuring apparatus shown in the diagram below. So A will have conical flask, no. Then density bottle, no separating funnel. So the answer is volumetric flask, because we can see that it has this volume of 250 mils here. Then we move on to question 3. What term is given to atoms of the same elements with the same atomic number but different mass number? So we are dealing with the isotopes. So the answer, this is our C here. Then if we move on to question 4, metallic bonding is the so if you look at metallic bonding, we can't look at this one as loss and gain, no. Then sharing of electrons between, no. Force of attraction between valence electrons and the metal ions, no. So it has to do with the electrostatic force that exists between all protons and all the electrons. Then for question 5 here, which one of the following oxides can be neutralized by both aqueous sodium hydroxide and sulfuric acid? So sodium hydroxide is a base. Then we have here sulfuric acid. So here this question is asking us to find the amphoteric oxide, because the amphoteric oxide can react with a base and an acid to give us a salt and water. So from these multiple choices, we want to find the example of such an amphoteric oxide. So among copper oxide, magnesium oxide, iron 2,3 oxide, and lead oxide, which of these is an amphoteric oxide? So the answer is lead oxide, because these are basic oxides. So copper oxide is basic, magnesium is also basic, then iron is also basic. Then let's move on to question 6 here. Start the reaction scheme below. We have black solid A reacted with dilute sulfuric acid. Then he gave us a light blue solution B. Then he reacted with sodium hydroxide followed by excess of it, light blue PPT. Then PPT persists insoluble in excess D. Then liquid C. Identify the black solid A and liquid C. So the black solid, we know that this is copper oxide. Then what's our liquid C? So liquid C here is just water. So this is our answer here. Then we move on to question 7. 8.7 grams of pure zinc metal was reacted with 100 cubic centimeters of 2.0 mol per cubic decimeters hydrochloric acid. Which one of the two substances was a limiting reagent? Reactant in excess and correct formula for our product. So we can't tell if we don't have the equation. So the first step here, we are going to make the equation. So the equation is, we know that we have pure zinc reacted with the hydrochloric acid HCl. Then the product, this will give us zinc chloride then and hydrogen. Okay, so now away from here, we know that for us to balance the chemical equation, we just have to put 2 in front of HCl. Then after we've balanced this, we need to find the number of moles for zinc. So we can see that we have been given the mass. So say number of moles is equal to mass over molar mass. So the mass is 7.8. Then the molar mass, since zinc is just a pure metal, according to the periodic table, zinc has the mass number of 65. So say 7.8 divided by 65. So I'm getting 0.12 moles. So these were the moles for zinc. Then we also need to find the moles for HCl. We can see that we have been given the volume and the concentration. So number of moles is equal to concentration multiplied by volume. So the concentration is 2.0. Then what's our volume? So volume is 100. So say 100 divided by 1000, since we need to convert this to the decimeter cubed. So say 100 divided by 1000, I'm getting 0.1 times 2. So here I'm getting 0.2. Now after we are done finding the number of moles, we are supposed to divide each number of moles by the mole ratio. So the mole ratio for zinc is the number in front of zinc, which is 1. So you know that 0.12 divided by 1 will give us 0.12 moles. Then for this one, the mole ratio is just 2, so we divide by 2. So what is the 0.2 divided by 2? So the answer is 0.1. Now we need to compare. So between the number of moles of zinc and that of hydrochloric acid, we have to compare which one is the smaller one. So you can see that 0.1 is smaller than 0.12. So HCl is our limiting reagent. So limiting reactant is hydrochloric acid. So you can see that option B is option B and D. These two both have HCl. Now for excess, the one in excess, this will be our zinc. Then the chemical formula. The chemical formula here we have zinc chloride, then plus H2O. This one is, there should be an error here. So pure zinc metal reacted with HCl, we know that the hydrogen will be produced. Now 7. Maybe let's do the calculations, because we know that HCl is our limiting reactant. Then zinc is in excess, but the chemical formula here, this chemical formula is quite okay, but the product, we don't have water. We are supposed to have hydrogen. Maybe let's redo. So we have 7.8 divided by 65. The mass number for zinc is 65. I'm getting 0.12 divided by 1, so this one is okay. Then 100 divided by 1000, 0.1 times 2, 0.2 divided by 2, 0.1. So then there should be an error. So the answer must be B, but we can't produce water. There is no way in which a pure metal can produce water whenever it reacts with an acid. So we are expecting to have hydrogen. So the answer is this one. So limiting reactant is HCl, because 0.1 is less than 0.12. Then the one in excess is zinc. Zinc is in excess. So that is the key point here. Then for 80, how many moles of oxygen gas would occupy a volume of 1,200 cubic centimeters at room temperature and pressure? So this is at RTP. So we want to find the number of moles. So if you are given volume, the number of moles is equal to volume divided by molar volume. So what is the volume? We have 1,200 cubic centimeters. So remember, the volume must be in decimeters cubic. So we need to convert 1 decimeter cubic centimeters is equal to 1,000 cubic centimeters. Then the 1,000 cubic centimeters 200 will be here. Then if we cross multiply, here we are getting 1,000 cubic centimeters x is equal to, here we have 1,200 cubic centimeters multiplied by decimeter cubic. Then you divide by this, also here by this. So we know that our answer will be 1.2 decimeters cubic. So the point here is, if you are let's say you have 1 decimeter cubic, the conversion is equal to 1,000 cubic centimeters. So if you are converting from decimeter cubic to centimeter cubic, multiply by 1,000. Then the reverse is also true when converting from centimeter cubic by to decimeter. So here you just divide by 1,000. So the volume is now 1.2 over molar volume. Whenever you have RTP, the molar volume is 24. So we divide by 24. So if we do the mathematics here, 1.2 divided by 24, we get 0.05. So I'm getting 0.05 moles. This is our answer. So you can see that the multiple choice is A here. Now we can move on to question 9. A learner carried out 4 experiments on rates of chemical reaction. The results of the experiments were recorded on a graph as shown below. So we have reaction 1, 2, 3, 4. Now let's look at the question here. So the question is, which reaction shows the fastest reaction? So the fastest one is this one. So this is the fastest. Then followed by 3, this one, then this one. So how do you know that this is the fastest? The one closest to the y-axis is the fastest. So the answer here is just D here. Okay, so move on to question 10. Element W has high boiling and melting point. It forms 2 oxides. We have this and this. This element is A, an alkaline earth metal, B, a chalcogen, then D, we have a transition, then C, a transition, D, we have the halogen. Now, because of the high boiling and melting point, so we know that this must be a metal. So the answer here is it is a transition. So transition, some of the transition elements behaves like that. Now we move on to question A11. Rubidium is in group 1 of the periodic table. Which element is in the same period with rubidium but found in group 5? So this one we need a guidance from a periodic table. So according to the periodic table, rubidium is in group 1 and it is in period 4. Then we want the element that is which element is in the same period with rubidium but found in group 5. So whenever you are using a periodic table, go on the rubidium, then move in the same period but go in group 5. So according to my periodic table here, the answer here is just C, SB. You find this one, antimony. That's how this one can be read. Okay, so we go to question 12. Metals are able to conduct electricity because they have delocalized electrons. Their particles are closely packed. They form ionic compounds. They are ductile. So the answer is just A. They have delocalized. So delocalized electrons means the electrons are free to move. Whenever we have free mobility of electrons, therefore we have these characteristics of conductivity of electricity. Now we move on to question 13. A learner set up the following experiments using ionels. So here we have tap water with Xc, then ionels. Then here we have oil, boiled water, then ionels. Then here we have ionels, then cotton wool, calcium oxide. So in which test tube or test tube will the nail rust? So we need to look at where rust is able to take place. So the only test tube where we can have rust is only test tube X only. Why? Here we can see that there is water. So there is water, and since the test tube is open here, we can see that we are going to have the presence of atmospheric oxygen. Now for this, since water is boiled, there is no oxygen here, and since there is oil here, oxygen cannot pass through. Then in this one we have cotton wool and calcium oxide, so that cannot allow rust to take place. Then 14, which gases make up more than 90% of dry air? So A, nitrogen, argon and carbon dioxide. B, nitrogen and carbon dioxide. Oxygen and carbon dioxide. Oxygen and nitrogen. So let's look at the percentage for nitrogen. We know that nitrogen depends with the textbook. In some books you may find it nitrogen to be 70-80%. Then oxygen is about 21%. So if you add this will give us 90+%. So it's oxygen and nitrogen, because carbon dioxide is about 0.04, so that won't reach 90%. Okay, so now let's move on to question 15. In a particular laboratory, the following elements were in stock: zinc, copper, sodium, carbon, and iron. The arrangement of the elements in order of their decreasing reactivity. So first begin with sodium. So sodium is the most one. So A, B cannot be the answer. So let's look at A. So A or D, because carbon is not as reactive as iron or zinc. So which one is the most reactive? So after sodium there is so the answer here is we have sodium, iron, carbon, zinc, then copper, then zinc. So the answer is D. Why? Because the first one, sodium, is more reactive than iron, carbon, zinc, and copper. Iron is more reactive than carbon, zinc, and copper. Carbon is more reactive than zinc and copper. Okay, so that is the point here. Then for question 16, the diagram below shows the setup used to detect the presence of carbon dioxide in polluted air. So polluted air here, then to filter pump, then we have X here. So what is our question? Solution X is the first one, aqueous calcium hydroxide. B, aqueous lead to nitrate. C, aqueous potassium hydroxide. D, aqueous sodium nitrate. So we want to look at the substance that we can use to detect carbon dioxide. So the answer here is aqueous calcium hydroxide. Okay, so let's move on to question 17 here. The diagram below shows the fractional distillation of crude oil. fractionating column, then crude oil. So okay, now let's look at the question. So which explanation below is correct? Reason for fraction H, so our interest is here, to be collected below fraction G. Okay, so let's look at these two. Now H and G. So H, average molecular mass. So we know that whenever, if we are moving down, their molecular mass increases. So H must have greater than G. So greater is either A or C. Then boiling point of H, boiling point of H higher than G, lower than G. So the answer here is C. Why? H has the greater average molecular mass of G, but H, in terms of the boiling point, the one on top has the lowest or lower than the one below. So we move on to question 18. The substance that conforms to a homologous series with the general formula CN2N is. So these are alkanes, or this is the general formula for alkane. So the first one, butanoic acid, no butene, so the answer is just C here. You can see this ENE. Okay, so now we move on to question 19. Which one of these organic compounds will decolorize bromine vapor? So the compounds that has the ability to decolorize these are alkanes. So we need to have an alkene. So from this, let's look at an alkene. So this is an alcohol. This is propanol. Then here we have butene. So this is our answer because here is butane. So the answer is just B. So the point here, what you need to commit to memory is alkenes have the ability to decolorize bromine vapor. So we move on to question 20. Start the organic structures below. So from these structures, we can see that here we have OH. This tells that we are dealing with an alcohol. Now, then for this one, we can see that we have something like a cyclo because it is forming a ring. Then here there is a double bond here. We are dealing with an alkene because of the double bond. Then here we also have a double bond. We have another alkene. Then let's look at the questions. Which of the above structures are isomers? So we want to look at the isomer. So the first one, let's look at the molecular formula for structure 1. So structure 1, there is 1, 2, 3, 4. So there are 4 carbons. Let's count the hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there is 9 plus OH. So this is the chemical formula. Let's look at this one. So we have 4 carbons. Then hydrogen, we have 1, 2, 3, 4, 5, 6, 7, 8. So 80. Let's look at this one. So for this one, how many carbons? 1, 2, 3, 4. So it's 4. Then hydrogen, 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is our first chemical formula. For this one, then for this one we have 1, 2, 3, 4, 5. So we have 5. Then hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see that we have 10 hydrogen here. So it's 10 hydrogen. Now, from this, we need to look at where we have the same molecular formula. So we can see that here we have C4H8, even here C4H8. So these two are isomers. So it's one, I mean not one, this is 2 and 3. 2 and 3. So this is our answer here. Okay, now we can move on to section B. Answer all the questions. Answer all questions in this section. Write your answers in the spaces provided on the question paper. Question B1, describe the type of movement of particles in the first one, solid. So if we look at the structure for a solid, we know that the particles are closely packed. Now what happens if we are looking at the movement? The particles does not move, they only vibrate at a fixed position. So say they only vibrate at a fixed point or position. Then for liquids, they are able to move. They are able to move according to the container. So it depends with the container where they are placed in. Then for question B, chemistry has been found to improve the livelihood of mankind. State any 2 benefits of chemistry to mankind. So there are so many benefits of chemistry. We have some of these in homes, then even in the community at large, then also in industry. So we'll say the first one, to manufacture. Chemistry is used to manufacture like fertilizers is chemistry. Then manufacture of cement is chemistry. Then in so to extract minerals in mines is chemistry. Then in homes we have like cooking requires chemistry, washing requires chemistry, formation of explosives, that is chemistry. Then washing is also chemistry. Now let's move on to question B2. The diagram below shows one of the laboratory apparatus. So we can see that we have a tap here. Now you need to be careful. If you have, let's say, something like this, then and you have this is the structure for a burette. Now whenever we have a shape like this and a tap, so this is a separating funnel. Then you move on to B1. State the use of the apparatus shown above. So what is the use of separating funnel? So to separate immiscible liquids. So immiscible liquids are liquids that does not mix completely to form a uniform solution. Suggest 2 substances that can be separated by the apparatus shown above when combined. So an example of these substances are water and cooking oil. So just say water and oil. And why does this element say, why can't they mix? Because water is more denser than oil. So for substances with different densities, they are likely not to mix if they are to put in one container. Okay, so now let's move on to question B3. In chemistry, substances are classified as elements or compounds. Distinguish an element from a compound. So say an element is a pure substance. Is a pure substance with one kind of atom. whereas a compound is a substance with two or more elements that are chemically combined. So that's a point here. Then also an element we can say is a pure substance that cannot be split or broken down. Okay, so now let's go to B. The table below shows the chemical formulae of some substances. So the first one here we have ammonia. So this is our ammonia. We know that in ammonia we have the atom of nitrogen and the atom of hydrogen. Then here we have hydrogen diatomic. Then for this one we can see this is sulfur dioxide. So sulfur dioxide. Then here we have oxygen. So from the table above, classify the substances into elements and compounds. So substances that are compounds is the first one, NH3. Why? There are two kinds of elements. There is hydrogen and nitrogen. Then the second one is SO2, which is sulfur dioxide. Then elements, we have hydrogen, then oxygen. So that's how we can answer a question like this one. Okay, so now we move on to question before. Start the reaction scheme below. Dilute sulfuric acid is equal to, plus magnesium metal is equal to salt A plus gas B. So what is the concept? So the concept is if you have a pure metal plus any acid, you are going to get a salt plus the gas that is produced is what? Hydrogen. So from this we know that the gas B will be hydrogen gas. So it's a statement that you are supposed to know that whenever a pure metal reacts with an acid, salt and hydrogen gas must be produced. Now, if we now use the metal, which is magnesium, plus the sulfuric acid. So now the pattern is from the sulfuric acid. Whenever you're naming a salt, the metal does not change, so the metal will be magnesium, like the way it is. Then from the sulfuric acid, we get sulfate. So this becomes magnesium sulfate plus hydrogen gas. So substance A or salt A is magnesium sulfate. Then we move on to question 2. Magnesium sulfate is an ionic compound. Write the chemical formula of all the ions that form magnesium sulfate. So magnesium sulfate has, magnesium has a valence of 2. Then sulfate has also a valence of 2. So if you are to cross, we know that these two numbers will cancel. So the chemical formula for magnesium sulfate is this. Now in terms of the ion, so we'll say magnesium Mg, then plus 2. Then sulfate is SO4 minus 2. So these are ions. Write a balanced chemical equation showing set symbols for the reaction between magnesium and dilute sulfuric acid. So magnesium is Mg, solid, plus sulfuric acid is H2SO4 aqueous. Then we know that magnesium sulfate is MgSO4 aqueous plus hydrogen diatomic gas. So for a reaction like this one, we know that we have a balance because we have 2 atoms of hydrogen on the reactant and 2 atoms of hydrogen on the product. So this equation is already balanced. Then for B, name the acid that is found in sour milk. So the acid that is found in sour milk is lactic acid. Like from lactation, lactogen, so that's a concept here. Then for question 5, calcium oxide is produced by heating limestone following the reaction below. Determine the relative formula mass of the calcium carbonate. So relative formula mass is just Mr. Now for calcium carbonate, here it's like this. So there is 1 atom of calcium, 1 atom of carbon, 3 atoms of oxygen. So we'll say calcium multiplied by 1 plus carbon times 1 plus oxygen times 3. So calcium is 40 times 1 plus 12 times 1 plus 16 times 3. 40 multiplied by 1 is 40. Here we have 12. 16 times 3 will give us 48. 48 plus 12 is 60 plus 40. So the relative formula mass for calcium carbonate is 100. Then we go to determine the mass of calcium oxide produced if 400 grams of calcium carbonate is decomposed fully. So let's first write our chemical equation. Now for equation like this one, it's a balanced chemical equation. Now let's look at the mass that we are given. So we are given 400 grams, and this 400 grams is for calcium carbonate, so we'll write it here. Then we want the mass of calcium oxide. So the mass for calcium oxide we don't have, we put X. Then from there we need to find the relative formula mass for calcium carbonate. We have it already, so it's 100. So if in a case where we haven't find this 100, we are supposed to find it. Then let's find the relative formula mass for calcium oxide. So calcium oxide, there is 1 atom of calcium, 1 atom of oxygen. So this will be calcium times 1 plus oxygen times 1. So where there is calcium, we put the mass number 40 times 1 plus 16 times 1. 40 times 1 will give us 40 plus 16. So here we are going to have 56. So this is the number that we are going to put here. Then we can cross multiply. 100 times x is 100x. Then here we have 400, we multiply with 56. So to solve for x, we divide by 100, also here by 100. So if we cancel, we know that here we have 4 times 6 is 24 carry 2. 4 times 5 is 20 plus 2, that is 224 grams. So this was the mass of the calcium oxide. Then we move on to question C. Give one natural and one artificial use of the gas produced in the reaction above. So the gas that is produced during the decomposition of limestone to give us calcium oxide and I mean the carbon dioxide is the gas that is produced. So the natural use of carbon dioxide, the natural means is photosynthesis, because photosynthesis is just a natural process. Then for artificial use, we can say to make carbonated drinks. So to make carbonated drinks. Then in the other use we have like brewing. Then also baking. Apart from baking, in fire extinguisher. So all these are artificial use. Then we move on to question B6. The reaction between 4.2 grams lump of magnesium carbonate and 0.21 molarity hydrochloric acid is relatively slow. The reaction can be increased by either increasing the temperature or using a catalyst. Roman number 1. Other than increasing temperature and using a catalyst, state any 2 conditions that can be applied to the reactants in order to increase the rate of chemical reaction. So apart from temperature, then and a catalyst, so we can say by increasing the concentration of the reacting particles. So key point is, if you just increase the concentration, the rate of reaction will increase. Then condition number 2, by reducing the size of the reacting particles. We know that particles with smaller size tend to react faster compared to the one with larger in terms of the size. Then Roman number 2, explain how a catalyst would increase the rate of a chemical reaction. So this point is, we can say by lowering activation energy. So what is this activation energy? Activation energy is the small amount of energy that is required for a reaction to take place. Now here we want to balance this equation, so we move on to question B. So first begin by balancing nitrogen, so we need to put a 2 here, so we know that B is 2. So 2 atoms of nitrogen, 2 atoms of nitrogen. Now if we multiply 2 times 3 will give us 6. So what number can we multiply by 2 to give us 6? So we need a 3 here. So this is how we can balance it. Then apart from temperature and catalyst, mention one other factor that can increase the rate of production of ammonia in the equation. So here there are 3 conditions that must be there for the formation of ammonia in the Haber process to succeed. So apart from temperature and catalyst, the other one is pressure. So we need the pressure. Then we move on to question 7. Group 8 elements of the periodic table are also called group 0. Explain why group 8 elements of the periodic table are referred to as group 0. So the reason why they are referred to as group 0, they have a valence of 0. A valence of 0. In actual sense, we can say they are just what? Stable. Their outermost shell are electrically filled. So what common name is given to group 0 elements of a periodic table? So they are known as noble gases or inert gases. Okay, so now we move on to C. Group 0 elements of a periodic table have practical use in everyday life. Give one use of the first one, argon. So in ordinary bulbs. Then neon in advertising signs. Okay, so now we move on to question 8. So question 8 here. One of the ores from which zinc is extracted is zinc blende. What is the chemical name of zinc blende? So this is known as zinc sulfide. Then for B, zinc blende is roasted in air, producing zinc oxide and a gas that should not be allowed to escape into the atmosphere. Name the gas. So during the extraction of zinc, there are 2 gases that are produced. The first one is zinc sulfide, and the second one is zinc carbon monoxide. All these 2 gases are very negative in terms of if they were allowed to go into the atmosphere. Now here, which gas are we looking at? So the first gas that is produced, if we have zinc sulfide plus oxygen. So roasted in air is oxygen. So the first one will give us zinc oxide plus sulfur dioxide. So the gas that we are looking at here is sulfur dioxide. Now, what is the negative impact? Why should you not allow the gas to escape into the atmosphere? Because if it happens to dissolve in the atmospheric vapor, it may produce the acidic rain. Because it can produce acidic rain if allowed to go into the atmosphere. Then we move on to zinc oxide is reduced to zinc made at a high temperature by a reducing agent. Name the reducing agent. So the reducing agent here is just carbon. Then I've seen some people thinking the reducing agent is carbon monoxide. No, the carbon monoxide is the reducing agent during the extraction of iron. But for this one is carbon. You can research for that. Then construct the weight equation for the reaction. So this weight equation is like this. So it's carbon plus zinc oxide. We know that carbon is more reactive than zinc, so this will give us carbon monoxide. And be careful, the gas that is produced this time is carbon monoxide plus zinc. So the zinc oxide has been reduced to zinc. So this is a redox reaction. D, give one use of zinc. So to make an alloy such as brass. In brass there is copper and zinc. Move on to question 9 here. So a thin C2H4 is an unsaturated hydrocarbon. It is manufactured from petroleum as shown in the flowchart flow diagram. So we have petroleum, process X, then kerosene, process Y, ethene, process Z, polyethylene. So let's first look at the process X. How can we convert petroleum into kerosene? We use refining by using the process of fractional distillation. So distillation, where the substance with the lowest melting point will be the first one to escape the fractionating tower. Then from kerosene to ethene, this is cracking, where a large molecule is broken into simpler one. Then from ethene to polyethylene, we can see the poly here. So this is polymerization. So we have answered Y is cracking, Z is polymerization, then describe either process X or Z, including necessary condition for any reaction. So Z, let's we have been given the chance to make a choice here, so we'll go with Z. Z is polymerization. If you want, you can go with a refining. Depends with the one that you think is easy for you. So say Z is polymerization. Then we'll say this is the process, this is the addition of smaller units known as monomers to form a large molecule molecule called a polymer. So this, then the condition is we need a catalyst here, given in the temperature. Then for C, ethene can undergo hydrogenation process with hydrogen. Write the reaction equation using displayed structure. Okay, so we begin with, we know that if we have an alkene, then E plus hydrogen, this is what we call the hydrogenation. You add hydrogen to an alkene, then the product changes from alkene to alkane. So from ENE changes to ANE. Then let's look at the word equation. So we have ethene plus C hydrogen. So this will change to ethane. So that's a pattern under hydrogenation. If this were to be propene, changes to propane. Then the chemical formula is C2H4 plus C hydrogen. Then we know that the number of carbons will not change. Then the hydrogen will add up. 4 plus 2, we get 6. Now we want to look at the structure. So the structure will be like this. The structure for ethene is this one with a double bond, since it's an alkene, plus C. Then we react with hydrogen. The key point is the double bond will break, so the product will only have single bonds. So we put the 4 atoms of hydrogen plus the other 2 atoms of hydrogen that we added. So this is our displayed structure equation. So now we can move on to section C. Answer any 2 questions from this section. Write your answers in the separate answer booklet provided. Okay, so let's look at this question here. The diagram below illustrates the laboratory preparation of ammonia. So construct a balanced chemical equation from the reaction being illustrated in the diagram above. So the reaction is between ammonium chloride. So ammonium chloride, the chemical formula is NH4 chloride aqueous plus C reacting with the calcium hydroxide. Also here it's aqueous. Then we know that the calcium will give us calcium chloride here. Remember, calcium is in group 2, so it has a valence of 2. Chlorine has a valence of 1. So if we use the criss-cross method, this will give us CaCl2 plus water. So hydroxide will react with 1 atom of hydrogen, giving us water. Then plus the ammonia NH3. Now we want to balance this equation. So how can we balance this equation? So begin with chlorine. So chlorine is 2, so we put 2 here. So if we put 2 here, we are going to also put 2 here. Now hydrogen, we can see that on the reactant side, this 2 times 4 is 8 plus the 2 inside the hydroxide, so 10. Then here we have 6, then we just need a 2 here. 2 times 2, 4 plus 6. Then the equation is now balanced. Then state the common name for substance X. Substance X is calcium oxide. Now, what is the purpose of substance X? What is the purpose of calcium oxide? So we know that from these products there is water. So how can we separate water from ammonia, or how can we make sure that the ammonia is dried out? That's the use of calcium oxide. So we say it is used as a drying agent. Then see, why is ammonia collected by using the method shown above and not above water? So the reason is because ammonia is soluble in water. Ammonia is soluble in water, so we can't use we don't use a soluble gas by water, because if we put that gas into water, it is going to dissolve. So because ammonia is soluble in water, so that's the reason why we cannot use this. Then describe the chemical test for ammonia gas. It tells damp, red, litmus paper, blue. So whenever you put a gas like this one in presence of, whenever you put a litmus that is red in color in the presence of this, then we are going to get the color to change from red to blue. State 2 uses of ammonia. So the first one, to make fertilizers. Then to make nitric acid. There are so many uses, like it is used as a refrigerant, it is used to make the TNT. Then we go to question C2. Both fats and proteins are natural polymers. Name the synthetic polymer that has the same linkage as the fats. So the synthetically with the same linkage, we have pteridine. Then proteins share the linkage with the nylon. Remember, pteridine and nylon are man-made. Then for B1, draw the type of linkage found in the synthetic polymer named in A1 above and name the linkage. So we are trying to name the linkage found in fats and pteridine. So this is the linkage. It's COO. Then the name of this linkage is ester linkage. Then synthetic polymers are non-biodegradable. What is meant by this statement? So we'll say these are substances that cannot be broken down or decay by natural means. Okay, so now we can move on to question C. The structure displayed below is for another natural polymer. Name this polymer. So this is a starch, or if you want you can just say carbohydrate. Then is this polymer an addition or condensation polymer? Give a reason for answer. So it is a condensation polymer. Why? Because during its formation, water is also produced. So under condensation polymer or polymerization, water is also part of the product. Draw the structure of the monomer used to synthesize this polymer. So the structure, we know that is glucose. So the structure for glucose is like this. And if you want more of this, you can just see I have dropped videos on organic chemistry based on this, so you can just search for this. You name what type of linkage is found in this. So this linkage, what type of name is this one? So this is known as a glycosidic linkage, or we can just say glycosidic bond. Now we move on to question C3. So aluminium oxide react with both dilute hydrochloric acid and sodium hydroxide in the presence of water. What term is given to such an oxide that behaves like aluminium oxide? So here this is an amphoteric because it can behave an acid. It can behave an acid as a base. Then state another oxide that behaves in a similar way like the aluminium oxide. Remember, we answered a similar question, but let's not use that. Let's not use lead oxide. We'll just say zinc oxide. So zinc oxide is another amphoteric oxide. Then C1, state the type of reaction that occurs between aluminium oxide and dilute hydrochloric acid. So this will give us water and salt. So such kind of reaction is known as neutralization reaction. Construct a balance equation to show the reaction of aluminium oxide. So aluminium oxide is like this, 2, then 3. Why? Aluminium has a valence of 3 plus HCl aqueous. Then this will give us aluminium Cl3 plus H2O. Now, how can we balance this equation here? So we can balance. Let's put if we put 3 here. So let's say we put there is 2 atoms of aluminium. So let's put 2 here. So 2 atoms. Then you have 6 chlorine. Then we'll put let's put 6 here. Then we'll put 3 here. Okay, so we have it balanced because we have 2, then 2 times 3, 6 chlorine, also 6 here, 6 hydrogen, 6 here. Okay, it's now balanced. Then the states 2 uses of aluminium and the properties on which they use depends. So the first one, to make electric cable. Why? Because it is a good conductor of electricity. A good conductor of electricity. That's a property. Then the other one, to make cooking utensils like pots, because it's a good conductor of heat. To make another one, you can write to make aircraft parts, because it is lighter. Also to make cans where we have drinks cans, because it does not corrode. Then carbon dioxide and water belong to different types of oxides. State the type of oxide to which each of the. So carbon dioxide, it's slightly soluble in water, so this is an acidic oxide. Then for water behaves as both an acid and a base, so this is another example of amphoteric oxide. So this is what I can share with you guys about this question. So that's it for this video. Thanks for watching.